Okay, so now we're going to look at the part D of the calculus question, 2016 mock, and that is got to do with acceleration. So acceleration is the second differentiation when it comes to calculus. So the first differentiation gives you speed or velocity, and the second differentiation gives you acceleration. So it says the greatest downward speed in the maneuver, so this is the stunt plane, occurs when the acceleration of the stunt plane is 0. Find d squared h dt squared, so the second differentiation. That's quite easy. We know what the first one is from the previous part of the question. So first differentiation, or f dash x, was t squared minus 15t plus 50. And we just differentiate with respect to t again. We bring our 2 down. So f dash dash x is 2t. Get rid of our t there, minus 15. And the 50 goes away. Use your answer from part 1, okay, to find the value of t at which the acceleration of the stunt plane is 0. So this is a little bit trickier, but again, all we're going to do is we're going to form an equation. So use your value of t, okay, from part 1. So we're using this part here. Okay, it's telling us to use this part to find the value of t at which the acceleration of the stunt plane is 0. So the answer has to be 0. So we're just going to go 2t minus 15 defines our acceleration. The answer is 0. If it wanted the acceleration of 100, we'd make it equal to 100, but we want the acceleration of 0, so we make it equal to 0. So we get 2t, bring your 15 over, becomes plus 15, and then t is going to be equal to 7.5 seconds. So that means that at 7.5 seconds, the acceleration of the stunt plane is 0. So stunt plane is going up and up and up. It hits this top point here where everything goes to 0. It stops effectively for a split second and then goes down, down, and down again. And finally, it says how to find the greatest downward speed of the stunt plane. So find the greatest downward speed of the stunt plane. Well, we know that speed, this is our speed. Remember, we differentiate, we get speed, and we differentiate, we get acceleration. So we're going to use this differentiation here. Our first differentiation is related to speed. So it's t squared minus 15t plus 50. So we differentiate, get speed, differentiate again, get acceleration. And what we do then is we sub in 7.5. So we go 7.5 squared minus 15 times 7.5 plus 50. So that will give us, sorry, let's mark that out away. So that will give us 7.5 squared minus 15 times 7.5 plus 50 gives us minus 6.25 meters per second. And we don't, the reason it's a minus is that the plane's on the way down. We don't include the minus, so it's just 6.25 meters per second. So we differentiated to get acceleration. We solved, right, to find when the acceleration plane is 0 or when it hits the highest point, and that takes 7.5 seconds. And then to find the speed on the way down, up here we sub in 7.5 into our first differentiation, that gives us speed, and it tells us that we're losing 6.25 meters per second in altitude.